All right, for this current week, we are going to discuss on a new topic, but this will just be a continuation of the previous topic. So for part one, we are going to discuss on slope-intercept form. I'd like you to consider this particular situation. A taxi charges a flat rate of $3 and an additional of $2 every kilometer traveled. So at this point, you should already be aware of how to analyze the situation. So here we can see that our independent quantity is distance in kilometers, and after knowing distance, we can find our dependent quantity, which is the total cost in dollars. Here we could also see that the rate of change every kilometer traveled would be 2. It means that the total cost increases by $2 every kilometer. Also, we can find that at the beginning, the taxi charges you $3. So this would become our y-intercept, which is represented by C. This means that you are charged of $3 at the start. So if we try to come up with a table from this, we can see that after 1 kilometer, the total cost is already $5. After 2 kilometers, the total cost is 7, and so on and so forth. Now, what is the total cost if I travel 15 kilometers? So in this case, you can continue the table, but doing that would take a lot of time. Other words, we need to come up with an equation to relate the two quantities x and y. And we are going to come up with a linear equation. We call it linear equation because the relationship that takes place here is a linear relationship. Thus, the equation we are going to form would be a linear equation. And based on our previous discussion last week, we can actually use the slope-intercept form y equal to mx plus c, wherein m is the slope and c is the y-intercept. So from here, we can say that the independent quantity will just be equal to the slope m times the value of the independent plus your y-intercept c. So given the following data, we can now come up with our equation as easy as y equals the slope 2 times x plus 3. And this equation is what we can use in order to solve the problem. So if I travel for 15 kilometers, then my x would be equal to 15 because x here is the distance, remember? So 2 times 15, that would be 30 plus 3, that will result to $33. Now, how about if the question is, how far did I travel if I was charged $20? Now, take note that $20 is the total cost. And the question, how far, is asking us of the distance. Therefore, we are given the y quantity and we are asked of the x quantity. So using the same equation, we can now substitute this as 20, which is the y, equal to 2 times, we don't know the x, plus 3. So we can manipulate this by isolating the x, meaning the x should be the one to remain on one side. So to do that, we have to transfer the 3 to the other side. Thus, we can have 20 minus 3, which gives us 17, equal to 2x. And to find for x, we need to divide both sides by 2. And by doing that, we get 8.5 kilometers. So a $20 charge would be given for a distance of 8.5 kilometers. And that's how useful a linear equation is, because you can find any quantity given the value of the other quantity. You don't have to come up with a table. You can just do it any time with the equation. Let's have another question. Let's consider another question. So pause for a while and read this situation. From this situation, we can find that the independent is the time in minutes, while the dependent is the height above the ground, which is in feet. Also, we can find that the slope is negative 2,000, which means that there is a decrease of 2,000 every minute. So this can be looked at as the height of the plane above the ground decreases by 2,000 feet every minute. Also, we know that the plane starts 30,000 feet above the ground. So this is the starting height. All right. So using the slope-intercept form, we know the slope and the y-intercept. Therefore, the equation now is y equal to negative 2,000, which is the slope, times x plus 30,000. Now, if the question is, what is the height of the plane after 10 minutes? So 10 minutes is the time, so that is our x. And we're looking for the height, which is the dependent quantity. So we can now substitute it in the equation. We now have y equal to the slope times the time plus 30,000. And simplifying it, we get 10,000 feet above the ground. So after 10 minutes, the plane is 10,000 feet above the ground. Now, if the question asks how many minutes for the plane to do a complete landing, if you try to analyze complete landing, meaning the plane is already on the ground. So the height of the plane would be 0 because it's already on the ground. All right? So that's the height, and we're asked of the minutes, meaning the missing quantity here is the x. Okay, so if we try to substitute it 0, which is the height, equal to negative 2,000x plus 30,000. So if we do algebraic manipulation here, we have to isolate the x so we can solve it. So move 30,000 to the other side, or instead of doing that, if you move 30,000 to the other side, this becomes negative, or 0 minus 30,000, which is negative 30,000. So I think you don't want to see negatives. So here, be wise. Try to strategize. For you not to see any negatives, what if this is the one that you're gonna move to the other side so that this becomes plus 2,000x. Therefore, you don't see any more negatives. So we can now have 2,000x equal to 30,000. To find for the x, divide both sides by 2,000, and thus you will get 15. Thus, it takes 15 minutes for the plane to complete a landing. All right? So if you try to look at this one, we are actually, at the beginning, I am asking you of how to solve it, and we mentioned the word linear equations. So these are actually the linear equations that we were able to form. So if you try to closely inspect linear equations, because later on you will encounter different types of equation, and this is the very basic equation you will see, linear equations. So if you try to look at it, if you try to look at the variables, specifically the exponent of the variables, you will see that in both equations, the variable y and the variable x will have an exponent of 1. You might not see it, but recall in our previous discussion, if there is no exponent, automatically it's having an exponent of 1. So a linear equation is an equation in which the highest power of the variable is always 1. Sometimes, or most of the times, it is known as 1 degree equation, meaning the degree of the equation is 1. These are examples of linear equations. Okay? So the first one, if you try to look at it, inspect the variables are having an exponent of 1, both of them. So we call it linear. But for number 2, variable x has an exponent of 2. Therefore, this is not a linear equation. For number 3, x has an exponent of 1, but then y here has a certain symbol, which will be discussed later on. Now, later you will understand and come to discover that this symbol leads you to an exponent of, or power of 1/2, which will be discussed later on. Therefore, this is not a linear equation. Fourth, look at the variables. All exponents are 1, therefore it's linear. Fifth, obviously this is not linear because the variable or power of the variable y is 2. Another example is this. If I have 1 over y equal to 2x, you might conclude that this is linear because the exponent of x is 1 and the exponent of y is 1. However, if you apply laws of exponent, recall our discussion before, if you have a number below, we can put it on top by putting it on top, or by finding its reciprocal, the exponent becomes negative. Remember negative exponent law? Putting a number on top makes its exponent negative. So if we try to put this on top, it becomes y to the power of negative 1 equal to 2x. Therefore, this variable y is not having an exponent of positive 1. Instead, it's negative 1. Thus, this is not considered a linear equation. Okay, so these are linear equations, and this is how to find whether an equation is linear or not. All right. Now, for the linear equations, we have slope-intercept form, which is given in these examples. We also have what we call as a general form, and the general form is just coming from the slope-intercept form. All we have to do is to rearrange the terms, and it should be in the form ax plus by equal to c. So all you have to do is to put all terms with the variables on the left side, and the one without, we call it the constant, and without a variable, it should remain on the right side. That's just the general form. So if we write this in the general form, we just have to transfer 2x to the other side and leave the constant on the right side. So all constants must be on the right side. If we do that, this becomes y minus 2x equal to 3. And we have to write x first, so we can just rearrange it. It now becomes negative 2x plus y is equal to 3. Therefore, this is the general form of the first equation in slope-intercept form. Similarly for this, we just have to do the same process. So that's y plus 2x is equal to 30,000, 2,000x is equal to 30,000. And then just rearrange this so that x comes first. Thus we got 2,000x plus y is equal to 30,000. And that's how to write linear equations from slope-intercept to general form. How about if you're given general form and then we are going to write it in slope-intercept form? In slope-intercept form, remember that y should be left on the left side, should be alone on the left side. Therefore, the rest should be transferred to the right side. So to write this in slope-intercept form, we just have to transfer 6x to the other side. Thus, it becomes 2y equal to x should be written first, negative 6x plus 10. So y should have a coefficient of 1 here, so we divide both sides by 2. Thus, we get y equal to negative 3x because we divide this by 2 and then plus 5. So here, the slope is negative 3 and the y-intercept is 5. Now, for the second example, so same process. We have to leave the y alone on the left side. So transfer 3x to the other side. We have negative 6y. Take note, this is negative 6y. This is minus. So this must be negative. We are only transferring the 3x. So this must remain to be negative. Negative 6y equal to negative 3x minus 8. Divide both sides by negative 6 so that we will only have a y remaining. So we now have y equal to negative 3 over negative 6. So right now, I'm only dividing the numbers. Whatever the result, that will be the coefficient of the x. Minus, this is minus, positive 8 over negative 6. But if you try to look at it, negative and negative, dividing them makes it a positive. This one gives you a negative. But because you have a minus here, minus a negative gives you positive. That is why the shortcut for this is if you are dividing a negative by a negative number, this becomes positive. Negative by a negative, this should result to a positive. So if you wanted to see the longer process, then this is the longer process. If you wanted to avoid seeing a lot of signs here, you can just do it mentally, or in looking at the signs, you can predict what the sign of the final answer is. So this now becomes 1/2 x, that's the simplified form of this, and this is simplifying this 4 over 3. The slope is 1/2, the y-intercept is 4 over 3. Okay? Now continuing, what if the situation is this? Pause the video and read, understand. So from here, we can see that the independent is time in hours, the dependent is the total cost. Now, further, if we try to put it in table of values, we know that in 2 hours, the total cost is 13. In 6 hours, it's 33. You are asked of how much is the cost for working 12 hours, or if the cost is 50, how many hours? So here, we don't know the slope. If you try to find the rate by dividing 13 by 2 hours, you might say Nicole's rate is about $6.5 per hour because 2 hours, that's 13. So meaning half should be 6.5. So 6.5 per hour. That might be your prediction. However, if you try to look at the second given, $33 for 6 hours, dividing 33 by 6 gives you an amount which is lesser than 6. This is 5 point something. Hence, the rate is not 6.5, or neither will this be the rate. The rate should be constant. In other words, it's not safe to divide 13 by the number of hours of working because we are not really sure if that is the rate. If that rate is also constant. Hence, we don't know the slope. Now, even if we don't know the slope, in our previous discussion, you were taught to find the slope, we have to find the change in the y over the change in the x. Here, we are given two different sets of data. The first data working in 2 hours, the second data working in 6 hours. And each x is given a certain y value. So here, we have to compute for our slope manually. So 33, which is the first value of y, the current value of y, minus the 13 over 6 minus 2. This is the change in the y, and this is the change in the x. And this gives us 20 over 4, or an m equal to 5. However, though we know the m, we do not know how much is the starting rate of Nicole. Thus, we don't know our y-intercept. Since we do not know our y-intercept, we can only come up with a partial equation, which is y equal to 5x plus c. Again, you might want to go back here to find the amount when x is 0, but that might be a longer process. So now, question is, how do we solve for the c? To solve for the c, we just need a certain value of x and a certain value of y. Alright? So that we can solve for the c. So the value of a certain value of x and y can actually be found in the table or from the data here. So here in the table, we have a pair of value of x and y. Actually, we have two of them. So just choose one. So let's choose the smaller value, this one. So if we choose this, then we know that at 2 hours, Nicole is charging $13. So this is a certain value of x and its corresponding value of y. So we can use these values in order to solve for the missing y-intercept. So to solve for c, just put in the values. So we have 13 equal to 5 times 2 plus c. That's 13 equal to 10 plus c. Therefore, your c is equal to 3. All right. Now, once we have the c, we can now come up with a full linear equation, y equal to 5x plus 3. And thus, we can now solve for the first question. How much will she charge if she babysits for 12 hours? 12 is the time. So the total cost y will just be 5 times the time 12 plus 3, which gives us $63. Similarly, for the second question, how many hours did she babysit if she charges 50? 50 is the total cost, we're looking for the time. So we can still use the same equation, but this time we have the value of y, we're looking for the x. Simply substitute, then manipulate, algebraic manipulation in order to isolate the x. Once it's isolated, divide both sides by the 5, thus you got 47 over 5 or 9.4 hours. I highly suggest that you use decimal or write it in mixed number because 47 over 5 is something that's not easy to understand. What do you mean by 47 over 5? That's quite abstract to understand, no? So better put it in decimal so we know that it's 9 hours or 9.4 hours, or write it in mixed numbered form. All right? So this will be my last example. Again, for my last example, I'd like you to pause this video, read, and understand. From here, we can see that your independent is time, which is in weeks, and your dependent is the total aluminum cans in pounds. Similarly, if we make the table, so these are the data that we can find, no? In 5 weeks, this is what he can collect, the total amount he can collect. In 8 weeks, this is the total amount he can collect. So how many weeks will it take for him to collect 200 pounds? Okay? So here we don't know the slope. Again, the slope is not given, but we can compute for the slope. change in y over change in x. So we have to find the difference in the y over the difference in the x. Alright? Thus we get 10. Again, we don't know as well how much he has at the beginning. We cannot assume it to be 0. So we don't know. So we just put a question mark. So from here, we can just come up with a partial linear equation in the slope-intercept form. So y equal to the slope 10 times x plus c. Again, to solve for the c, we need one pair of x and y so that this will not be variables. So we can just choose any from the table. Let's try to choose this one, 8 and 85. All right. So from here, we can substitute 8 to x, 85 to y. Thus, we got 85 equal to 10 times 8 plus c. Simplifying it, we get a value of c equal to 5. Thus, we now have a linear equation, y equal to 10x plus 5. And once we have the linear equation, we can now solve the problem. How many weeks will it take him to collect a total? That would be, that's asking the time given the total amount. So meaning we're looking for the x. So that would be 200 equal to 10x plus 5. Isolate the x. So 200 minus 5 equal to 10x. 10x is equal to 195. Therefore, we get 195 over 10 or 19.5 weeks. Or we say 19 weeks and half of a week. And that's how to solve linear equations. So for your assignment, this is something that we are gonna do tomorrow in class. But then if you can start today, a lot better to save time. So you may start in red or in yellow depending on what you say fit, no? But make sure to finish until green level by tomorrow. All right? Also, your notes will be checked tomorrow. Thank you so much, everyone.